Now we come to the category of fluid flow, in which we consider the flow with time. So it's broadly divided into two categories: steady flow and unsteady flow. The terms steady and uniform need to have a clear understanding of their meaning, because this will be used for solving of equations and also predicting the fluid flow that will occur down the stream. So we need to understand what do we mean by steady flow, what do we mean by unsteady flow, and so on. And then when we apply it to the equations or equations of motion, how do we apply it? What conditions do we put? The term steady implies that there is no change at any point in time. The opposite of steady is unsteady, as one can guess. So, broadly speaking, if we start the flow, let's say at 0 time, after 10 minutes or 30 minutes or 2 hours, the flow, there is nothing has changed. But if things keep changing, then it's a steady flow. But then there are other considerations also that we shall be looking at. This is a picture just to show you two conditions of unsteady flow and a kind of steady flow, not absolutely steady. So what is the difference? This is a cylindrical pipe that is attached to a flow, and then there is a block that is inserted, that is placed in between the fluid flow where the fluid is flowing. And as you can see that very close to the block there are eddy currents. The fluid is flowing in a manner that doesn't look smooth at all. In fact, it looks a little turbulence, it looks a little bit disturbed, and therefore it is behaving as one can see from the picture. But if we look at the picture on the right hand side, as we look at it, then the fluid flow appears to be steady after some time, and it appears to be smooth. The reason being that this frame was taken over a period of about 12 seconds, and you can see that the fluid flow appears very smooth. It has taken a particular shape, and then there are no eddy currents that appear there. Such type of flow is known as time average flow. We discuss as it comes. Broadly speaking, we need to understand and differentiate the implications of steady and unsteady flow while developing the equations of motion and looking for their solutions. So when we consider steady flows, it implies that there will be no change at a point with time, whereas for transient terms, which the transient term I will explain in a minute, in Navier-Stokes equations are 0. So what is the implication? If on time dependent the flow is not changing, then those things that are changeable with time, for example, the velocity or its component, the velocity vector or its component in x, y, z direction or whichever coordinates we are considering, will be 0. So therefore, the derivative, the change of velocity vector divided by time, du by dt or dv by dt, will be 0, as well as there will be no change in density or mass either. So rho, which is a sign of density for a particular fluid, will not change either, and therefore d rho by dt will also be 0. By definition of derivative, it is the ratio of the function with respect to time. So these two will be 0, and in Navier-Stokes equation, which we shall be developing and discussing later on in the course as we move on, we will impose these to be 0. And likewise, we shall see if there is something else that we want to reduce, then we apply this condition. But we need to be very careful and see where we can apply it, where we cannot. Unsteady is the opposite of steady. Transient usually describes a starting or developing flow. Periodic refers to a flow which oscillates about a mean. For example, harmonic motion, if it is taking place somewhere. Unsteady flow may appear steady if it is time average, as I have shown you in the picture that we saw a little earlier and we will see again. These meanings are consistent with their everyday use. For example, we use the terminology steady friendship, uniform distribution, like uniform distribution of electricity, uniform distribution of water over the country, uniform, etc., uniform distribution of wealth, and so on. So these terms, and a steady friendship is that if some people are getting on well for a long period of time, and with time nothing changed. So we are using this terminology in our everyday language as well, our everyday life as well, but it doesn't apply only to fluid flow. But here we are focusing ourselves on the time changes with respect to the fluid flow only. The terms unsteady and transient are often used interchangeably. Sometimes the transient flow is also, because it is changing, is also considered as unsteady, but they don't have exactly the same meaning. Unsteady flow will be a flow that keeps changing all the time. The transient flow is the one that changes in the initially, and there is change in the parameters of the fluid, but after certain time it settles down to a routine and uniform flow. So and it becomes kind of steady flow. So there is a clear-cut difference between unsteady and transient flows, and when we apply it to equations of motion, we should know where we are applying and what implications, boundary conditions, etc. we are imposing on the equation. In fluid mechanics, unsteady is the most general term that applies to any flow that is not steady, but transient is typically used for developing flows. When a rocket engine is fired up, for example, there are transient effects. For example, takes place when a rocket engine is fired, and we will come to this picture a little later again. In the engine, and the flow accelerates. So obviously when the engine is fired, the flow will accelerate and it builds up, and eventually when it develops a sufficient power, then the rocket takes off or the vehicle takes off until the engine settles down and operates steadily. So this is an example showing the transient effect of this is one example where such a flow is taking place. We come back to this picture, as I said earlier, and you can see that on the left hand side the flow is unsteady, but on the right side it's very calm and it looks smooth. Why? Because here in the first picture on the left hand side the flow is developing, and on the right hand side it has taken a shape after a while, and then the fluid flow takes this smooth flow as one can see it on the right hand side of the picture, and we have depicted it as time average flow.